Hello students, welcome to Turito School Foundation program. Today we would like to go for that school foundation program for the 9th class students. That is, we would like to discuss about 1D motion related problems. Let's have a look into that matter. For the 9th class students, we would like to go for that. Have the look. Yes, we would like to go for this 1D motion related problems. Yeah, while you are going to talk about that 1D motion, you would like to have few points to revise. Yeah, in case of 1D motion, you would like to confirm, that is the magnitude of the distance travelled by the body and the displacement is going to be equal, and the magnitude of speed and velocity, they are going to be equal, all right. So, we would like to confirm the motion of a body has been restricted to move along one direction, right. While you are going to take that vertical displacement, its velocity is going to depend on that g, that is acceleration due to gravity, and h, it is very clear. So, we can confirm that in case of 1D motion, the initial and terminal point both are going to be lying on that same line. Just you have to confirm. You can confirm that shortest path is the displacement. We are going to confirm, right. Just you will take that. A body starts from rest, all right, then moves with uniform acceleration. Okay, it's very clear. We would like to confirm this one. A body starts from rest and then moves with uniform acceleration. Then its displacement is directly proportional to square of the time. While you are going to take that uniform, in case of that uniform acceleration, we have to confirm this one, that is S is equal to ut plus half at square. Okay, if your body starts from rest, yeah, the body starts from rest, then its initial velocity is going to be 0, all right. Just you have to take this is equation number 1. And you can get the substitution, that is S is equal to 0 into t plus 1 by 2 a t square. In case of uniform acceleration, we would like to go for that, it is going to be constant. So, S depend on t square, all right. That is S is directly proportional to t square. This is very clear, all right. So, if it changes its direction, its velocity is going to be changed, all right. So, this is the case we would like to discuss. It is in the straight line. If it is going to change the direction here, so we can confirm here a is constant. It is not at all going to be, yeah, we have to confirm. If there exists a change in direction, there exists a change in velocity v, all right, it is very clear. Even though it is going to be moving at the same speed, due to the change in the direction, there exists a change in velocity. Yeah, it has to travel, along straight line, that is also one constraint. It is very clear, we would like to go for this one, all right. So, please look into the matter, yeah, that is very very important. It has to move in the straight line. Yes, these are going to be corrected. Yeah, these are the multi correct type answer. It is going to be, yes, it may move along circle. Yes, if it changes its direction, there exists a change in velocity. Yes, so this is going to be that first option and first and fourth one is going to be correct. Okay, right. Let us go for that. Another one. Okay, yeah, this is the basic model question. A particle covers the half of the circle of radius r, then the displacement and the distance of the particle are respectively. So, what we have discussed at the beginning of this class, in case of that straight line 1D motion, the magnitude of the distance and displacement both are going to be same, it is very clear. Particle covers the half of the circle, half of the revolution, just you have to take, right. So, if you are going to look into that matter, it is going to be very clear. So, you have to confirm. Just you have to yeah. Right. It is going to be covered. Yes. It will reach the terminal point. Very clear. This is going to be A and B, right. This is center O, all right. Let us assume R be the radius. Yes, it has been covered half of the circle, right. Yes, it will reach the destination from that point A. Let us assume we would like to talk about that distance covered by that body, all right. We have to go for this one, right. So, yeah, from the figure AB is equal to R plus R, that is 2R. AB represents shortest path. AB represents the shortest path between the two points, that is initial and the terminal point. If it has to cover the half of the circle, that is half of the revolution. If we are going to take that, R is the radius of the circle, okay, right. Shortest path. If you want to reach the destination or terminal point, you can define that number of ways, in any way that you can reach, yeah, that is going to be path independent. So, distance covered is path independent, okay. Yeah, you can reach in any path, just you have to get this one, but you have to reach that in this direction, that represents the displacement. So, in order to get that displacement, you have to consider AB is equal to R plus R, very clear. So, simply distance covered by that body, it never be 0, displacement may be 0, okay, all right. So, if we are going to take that 1D motion, distance and displacement, they are going to be equal, except that one, the distance covered by that body is going to be greater than that of displacement. Yeah, that is what we can define, distance is greater than or equal to displacement, which is going to be equal in case of 1D motion, it is very clear. So, AB represents the shortest path. So, AB that is the displacement, all right. So, AB is equal to 2R, very clear. It is the path dependent. Very clear. Now, you will get that distance covered. So, it has been covered in the circular path, half of the circle, that is 2 pi r by 2, it is going to be pi r, okay, it is very clear. We can go for that option, that is distance, yeah, displacement and distance. So, displacement is going to be 2r and distance covered. Yeah, if it is complete one revolution, it covers 2 pi r distance, all right. Okay, in half of that we can take that 2 pi r by 2, half of the revolution, it is very clear. So, apart from that you can learn one important concept. So, 3/4 of the revolution, let us assume in this way it has been covered. So, right, this is going to be C, if it covers that 3/4 revolution. Yes, you can define the shortest path, that is going to be, yeah, okay, yes, you can get this one. Yes. So, you will get that AC is equal to question mark. Apart from that you have to learn this one, it is easy for you. So, it is going to be just you have to find out this one, this is going to be the R. So, according to the Pythagoras theorem, just you have to take that AC is equal to root of R square plus R square. Yes. So, AC is equal to root of R square plus R square, that is root 2 R square, root 2 R, very clear. In that case, distance covered by that body or particle, yes, easily you will solve this one, all right. So, distance covered, yes, that is 2 pi r, just you have to get that, it is going to be that. Yeah, you will get that. Three by 4, 2 pi r, that is 2 pi r by 4 plus 2 pi r by 4 plus 2 pi r by 4, you will get that. This is going to be is yes, you can get this 1/4. You can get the problems based on this displacement and distance covered by that body. So, if it completes, it covers the distance of 2 pi r. So, 1/4 it is going to be getting here, after that here, yeah, after that here. So, easily you will get that 2 pi r by 4, yeah, like that. You can easily analyze that here pi r by 2, pi r by 2, just you will get that. So, yeah, here also pi r by 2, you can add that. Just you are going to take that sum, you can solve that problem. That is going to be the additional information. All of you get this one, it is very clear, you can go for that. So, you are all going to know about this to solve the problems from the concept, it is very clear. Everyone has to identify that. Let us move for another one. This is the answer for the given question. Yes, a ball released from a height falls 5 meter in 1 second. It's very clear. From the height, one ball which has been released, it reaches the ground. Okay. In 1 second, yeah, it covers 5 meter. What about in 4 second? This is going to be that x, we have to find out this one, right? A ball released from a height falls 5 meter in 1 second. In 4 second, if the it falls, yeah, it falls through. Let us assume we would like to go for this one, right? We know that, let us see that we can use this space. So, we know that S is equal to ut plus half at square. Okay. You can get that t is equal to 4 second, right? Now, you can solve the problem in 4 seconds. Distance covered, that is going to be S4, that is 0 into t plus 1 by 2 g into 4 square. So, 1 by 2 10 into 16, that is going to be 80 meter. Very clear. You can have that information. By this equation of motion we can solve the problem easily. We will solve the problem. It is very clear. Since u is equal to 0, what we have taken, u is equal to 0. So, while you are solving the problems, what are the advanced model problems apart from this? If you know that in a particular time what is the distance, vertical distance which has been covered by a body, then only you can estimate the total distance, total height. But they have given that in 4 seconds it falls through, that is the problem, just we have to see. So, even though they have given that the height or the vertical distance or the vertical displacement of a body in a particular time of its journey, in last 2 seconds, last 3 seconds or after another second, it will cover the distance. Then find out the total height of that ball from that top to ground. It is very clear, you can solve that very easily. So, we are going to talk about that V depend on G and H like that, right. Yes, if you are going to take that V, it is a displacement by time and distance. We can know that. So, easily we will solve that. The last, here t is equal to n minus 1 seconds. If it covers 5 meter, then you can estimate that height easily. Okay, that is, you will get that SH is equal to ut plus half at square. So, SH minus 1, that is going to be ut minus 1 plus 1 by 2 a t minus 1 whole square. In this method we can solve the problem. Okay. Let us see that what is the answer. So, we got that 80 meter, right. In the next level problems we are discussing, right. So, these are the another model problems we would like to get this one. So, answer is going to be that 80 meter, very clear. Let us go for another problem. Yeah, a ball is dropped downwards. After 1 second another ball is dropped downwards from the same point. Okay, it is very clear. This is also one kind of problem. You are going to get this one. This is the height, we are having that, right. One ball which has been released. So, here we would like to take that, this is going to be having that t seconds, it will reach the ground. Okay, after 1 second means you can take that t minus 1, just we have to take that. So, another ball released from the same height, which is going to reach the ground, this is t minus 1 second. Okay, very clear. Now, what they are going to ask you, if the time taken by the first ball to reach the ground is going to be 3 seconds, that is what it was confirmed, that displacement or vertical distance displacement of your body to reach the ground. The time taken by the body to reach the ground is going to be 3 seconds. The time taken by the second ball to reach the ground is going to be 2 seconds. Okay. If they have mentioned or not, let you know from the same point what is the distance between them after 3 seconds. Just we have to see, they are going to be in the right, it is also going to be here. You have to get this one, you have to find out this. Okay. It is very clear, you have to find this one. Distance means you are going to get that vertical displacement or vertical distance. Just we have to take this one, very clear. We can solve the problem, right. If it takes that 3 seconds, it is going to be 3 seconds. Yeah. So, this is going to be 2 seconds, all right. Right, we can easily solve the problem, right, you will get that. So, you know that equation of motion, that is for first one and second one we will apply. In 3 seconds of the time, what is that vertical displacement in case of the first one, in case of second one, what is the vertical displacement in 2 seconds. Just we have to solve the problem, and then we can confirm that if you are going to take that S3, that is going to be, yeah, this is going to be S2, let us assume, or H3, just we will solve that. So, this gives that S3 minus S2, all right, this is H, you can take that small h also, that is small h. In this way we can solve the problems. We have to adopt that problem and the case study, and we have to draw. If you are having that some information which was given with the problem. Okay, right. So, let us start that, we will use this space. Okay. You know very well about that, S is equal to ut plus half at square. This is the equation of motion we would like to consider, right. Very clear. For the first ball, it has been travelled that distance, right, in 3 seconds. Just we have to calculate S3 is equal to 0 into t plus 1 by 2. We have considered that is going to be g into 3 square, right. So, it is going to be 0 plus 1 by 2, 5 into 9, all right. Yes, you have to get this one, okay, right, 9 g by 2. What about the S2? It is getting 0 plus 1 by 2 into g into 2 square, that is g 4g by 2. Now, you can easily find that S3 minus S2, that is equal to 9g by 2 minus 4g by 2, very clear, we will get that 5g by 2. Okay, we can get that if we have been considered that g is equal to 10 meter per second square for our simplification, right. So, 5 into 10 by 2, it is going to be 5. So, you will get that 25 meter. Let us see the answer. Yeah, this is the correct answer. We would like to go for this one, that is 25 meter. Yes, have the look and get the answer. all right. Okay, let us move for another one. It is going to be right. So, apart from that, what you can estimate? You can calculate that height also, right, if they have been reached. If they have mentioned that time taken by that ball to reach the ground, if they have mentioned, just you have to apply that, and also you can calculate that height also, right. It is very clear. We would like to go for that one. We have taken that 1D motion, which is going to be limited to y axis or vertically in downward direction. It is very clear. We would like to go for that horizontal direction. The motion of a body or the motion of a two bodies which are going to be moving along the horizontal axis. Simply we would like to take this one. So, you have two special cases, that is, you are going to observe that the physical quantity, same physical quantity, which is going to be compared by the another one with the help of the relative motion. We would like to compare that the velocity or the speed, the acceleration of the two objects which are moving in the same direction or in opposite direction in the same frame. Just you have to look. If they are going to move in the same direction, we can consider the relative velocity or relative speed. Okay. If they are going to move in opposite direction, we can consider that relative velocity, that is going to be that sum of two velocities or speeds. Okay. It is very clear, but one thing we have to know that what are the possible cases? Crossing between the two moving objects or vehicles, one is crossing the other, right, very clear. One overtakes the other, right, it is very clear. Crossing, overtakes, these are the two cases we have to consider. While they are crossing, first one is going to cross the second one, depending on their speed and their capacities, it is very clear. So, in the crossing and overtakes, in two situations we are going to confirm their relative speed and relative velocity. Okay. That is what we would like to solve these kind of problems, whether they have given whatever it may be. Okay, two trains are each 50-meter long. Okay. Yeah, 50-meter long, moving parallel towards each other. Okay, very good. We have to get that two cases crossing. Just we are going to get that. Yeah, it is very clear. So, this is the case we have to confirm. Yes. So, you have to take that L1 and L2. So, V2 and V1 crossing, overtakes, just you have to get that takes, that is they are moving, first one is moving in this direction and the second one is also moving in this direction, which overtakes, right. Let us assume this is A and B, overtakes. So, they are having a speed which is different, right. In this case we have to consider V1, V2, V2 is greater than V1, all right. So, we would like to go for that V2 minus V1, difference of their speed, that is going to be the relative speed. Okay, if they have given the different model problems, what is the total distance covered? That is length of these two trains or the cars or vehicles or whatever. It is very clear. These kind of problems are very important, especially in entrance examination. So, you have to get the time taken by that first one or second one to overtakes and crossing, right. That is equal to question mark, you can get this one, right. We can easily solve the problem. Let us see the problem what they have given. Two trains are each 50 meter long, moving parallel towards each other. I think so this is the case we would like to consider, right, towards each other at speeds 10 meter per second and 15 meter per second respectively. After what time they will pass each other? So, yeah, we would like to go for this one. It is going to be moving in this direction, it is going to be moving in this direction. They will pass each other at a instant of time. So, at the time they have covered the distance, that is L1 plus L2, we have to confirm length of the train, yeah, which is going to be having that high speed, obviously it will cross that another one. So, the total distance travelled by that train which crosses the another one, that is length of the first train and the length of the second one also. Very clear, we can go for that, and we will take that their speed which is going to be relative speed. In this case, relative speed is equal to V1 plus V2, we would like to consider. This is very clear, let us have the look into that matter. So, we can ignore this one, this is not related to that problem. If sometimes if we require we can consider. So, they may ask you differently by assigning the task which are one is overtakes the another one, they are moving in the same direction, they are moving in the parallel track, the parallel to each other, both are in the both the cases they are parallel to each other, but while you are talking about the direction we have to look into that matter, that is going to be crossed and overtakes. Two case studies, first one and second one. So, the given problem is related to this one, we will erase this. Just we have to take this one, this is very clear. We have completed that explanation, we will take that problem and the given data, it may help you. Two trains, that is going to be 50 meter plus 50 meter, okay. Yeah, distance covered is equal to 50 meter plus 50 meter. Yes, it is going to be 50 meter and also 50 meter, all right. So, relative speed, that is going to be 10 meter per second plus 15 meter per second. So, 25 meter per second, it is very clear. If you know the distance and distance covered and time, then we can easily solve the problem. How much time does it takes that? Okay, let us see that. We would like to go for the calculation. Easily you will get that, that is T is equal to D by V, that is 100 by 25 meter per second, that is going to be 4. Let us have look into that matter. That is the answer. So, in this method we can solve the problem, we can analyze that problem and we will adapt all the possible cases. Okay students, thank you very much, have a nice day, let us meet in another classes having the advanced